Hello everyone. We already have learned about the different components in LangChain, like the prompt template, the chat models, which acts as a wrapper for the different LLMs that we are having, indexes and retrievers, memory, and so on. So we have dealt with each one of these components in one of our earlier sessions. So in this session, we are practically going to implement or create what a chain is by considering a couple of key components, one of which is the prompt template. And the other one here is going to be the chat models that we already have discussed. So before we get into practical understanding of it, let's discuss what each one of these is so that we are well aware of these components. So prompt template typically acts as a template which comprises of the user query. The user query is typically injected into this particular template so as to carve out a prompt from it. So apart from user query, we have a set of generic instructions to the LLM. And we also can have mock responses. Like mock responses are the ones that will help guide the LLM to provide responses in a similar format as that of the mock response. We also can enable few shot prompting or one shot prompting by providing certain examples within the prompt template. So the user query, whatever user query that we are having, is typically injected into this template so as to carve out the prompt, which will be sent as a request to your LLM. So that's the whole idea behind it. So we know that chain is a sequential set of functions, so which are executed sequentially. The output of one function or one component is typically fed as an input for your subsequent component. So let's consider that this is prompt template, and whatever prompt that you carve out from this particular function or entity is being fed as an input for your subsequent function, which is chat models. So what exactly is chat models here? So chat model acts as wrappers around your large language models that follow a message-based interface. These models typically support features like the role-based messaging. You assign roles to the messaging service that actually would occur. And it also enables multi-turn conversation context, right? So these are two main features of having chat models. So we can just think about chat model as a wrapper around your LLM, which provides some additional set of features like multi-turn conversational context, as well as it also supports some role-based messaging service. Cool. With all what we have learned so far, let's get back to VS Code and try to write the code for creating a chain, for which I am going to import the prompt template first from prompts module. So prompt template is a class which I'm importing from prompts module within LangChain. I'm also going to import the chat model, the OpenAI chat model. If you remember, I have already installed LangChain OpenAI in one of our earlier sessions, from which we are importing chat OpenAI. Along with this, let me also import LLMChain from chains module, with which we will construct a chain. I'm not sure if we will proceed creating a chain with LLMChain or we'll use other methods of creating a chain here. Okay. So we'll also look at importing load.n. So load.n is being helpful to us in order to load the environment variables. So I have saved all my environment variables in .env file. Just by simply executing this load.n or by invoking load.n, we are loading all the environment variables to your current execution context. So let me create a prompt by making use of this prompt template class. So I'm instantiating this class, but I'm also providing certain parameters or arguments like input variables. Let me consider a use case like trying to do a fundamental analysis of different stocks that are listed on NASDAQ. So that's why I'm just giving stock name here as one of the input variables. Okay. So along with this, we also would need to provide the template. So that's the whole purpose of it, right? So let's provide a template. So what could be the template here? The template can have an additional instruction like we have discussed earlier. Can you provide fundamental analysis of the stock or like for the stock? And within curly braces, I'm just providing the variable name that I have already defined, which is nothing but stock name here. Cool. So since we already have defined or created the prompt object, now is the time that we look at creating object specific to chat OpenAI. So as I've mentioned to you earlier, this chat model acts as a wrapper to your OpenAI GPT model. So we can also specify certain parameters like temperature I'm giving a value of 0 for temperature, so that I would want my LLM to provide responses which are completely deterministic. I'm not giving any creative freedom to LLM as such in this particular case. So now, in order to create a chain, we can make use of LangChain expression language, LCEL style of coding, which involves the different objects that we have created so far, separated by this pipe symbol. So we have created prompt object. We also have created chat model object. So this completes creating a chain. So this is a declarative style of coding. So apart from this, we also can make use of LLMChain class that we already have imported. And within this, we can provide what our LLM is. Our LLM is chat model, and we also can provide the prompt. The prompt is what we already have created in the previous steps. So this is yet another way of creating a chain, but this particular class is being deprecated now in the latest versions of LangChain. So this might soon go away. So that's why I'm not resorting to coding this way, but rather rely on LCEL style of coding, where we have chained the different objects that we have created pertinent to the different components like prompt template, as well as the chat model. So we basically have separated them by this pipe symbol, indicating that this is a chain that we have created. And now let me provide the stock name, because we have not provided the stock name yet. And we have not truly created the prompt yet. I'm just providing the stock name as Tesla. Okay. Sorry about the typo. And we can simply go about invoking this particular chain by providing the necessary variables that we already have provided while creating the prompt, right? What is the stock name here? The stock name here is going to be the stock name that we have defined in the previous step. And that's it. So now I'm assigning this to something called result. I can simply go about printing the result as a whole. Now I can select all the code and run this at once so as to understand if we get the proper response or not. So there is a key error. Input to prompt template is missing variable stock name. This is missing variable called stock name. So this is an input to the variable. So that's what it states. Looks like there is some typo here. Let's look at where the typo exactly here is. This is a typo. And let's save this code and let's rerun the code so as to understand if we get a proper response now or not. Let me expand this. Now you get a proper response for the given prompt that we have. So this is the instruction that we are passing to the LLM by using prompt template. We also have provided this stock name as the variable, which dynamically changes based on our needs and necessities. So here we have the content from the response that's provided by LLM, which indicates that it has provided some fundamental analysis, but I would want to report numbers as well. So can you provide, I can simply modify this prompt template stating, can you provide detailed fundamental analysis for the stock name backed by numbers. Okay. Now let me rerun this code and see if it's properly providing the response or not in the way that we would require. Cool. So now here you have the content, right? So let me see if we can just print the content alone and not print the complete response as such. Cool. So this is a fundamental analysis that's being returned from the large language model. The first one here is a revenue growth. So it has provided what's the reported total revenue and what's the percent increase when compared to previous year. What is the profitability, cash flow, debt levels, valuation, provides the PE ratio as well, and growth prospects of Tesla. So you can simply change the stock name to any other stock name and try to retrieve the response from LLM based upon the chain that we have created. So we made use of the prompt template so that whenever the stock name dynamically changes, the prompt is automatically carved out. So we're not creating the prompt again and again, but rather leveraging the prompt template by simply updating the stock name here. The generic instruction that we have passed to LLM remains the same here. Okay. As I've mentioned to you earlier, we can extend this prompt template to also provide mock responses to guide the LLM in a way to replicate how our response should look like. Okay. So I believe you have pretty much understood the whole process here. But if you do not want to use LCEL style of creating a chain, but rather leverage this LLM-chain class and instantiate the particular class by providing these parameters like LLM chat model for LLM prompt. So we simply can comment this code out, and the method here that we will use will differ a lot. Instead of chain.invoke, so we will have chain.run and simply provide the variable name here. The variable name here is going to be stock name. So we are passing this as a parameter while invoking this particular method called run. That's all. So this here is going to be LLM-chain and not chain anymore. So we can print out the complete result of it, like print result. Let's run this code. So here you have the response generated again, but you also can see a warning message stating that the class LLM-chain was deprecated in LangChain 0.1.17 and it will be removed in 1.0. So that's why it's always not recommended to use such deprecated methods or classes like what we are using currently, but rather leverage the LCEL style of coding a chain, like which is more like a declarative way of coding, and make use of this chat.invoke method rather than relying on chat.run. Sorry, chain.invoke rather than relying on chain.run. Okay. So that's pretty much all I wanted to discuss with you in this session. So in the next session, we'll see if we can extend this particular chain that we have created to include yet another component called memory, so that we maintain the complete conversational history or at least a summary of the conversation as a context while generating LLM responses multiple times, right? So if you would want to enable multi-turn conversational style of developing an application, then probably would want to include memory as yet another component. Okay, so that's all in this particular session, and thanks for watching.